So here we have our setup for conveying calcium carbonate. We have a feed station here that has a fluidization cone to allow a fluid bed to lift the product off the walls and prevent any rat holing. The product will convey from the feed station down to the feed adapter. There's a set of aspiration valves, a rear aspiration and a forward aspiration valve that will allow the product to aerate and convey in a dense or dilute phase or somewhere in between. From there, the product will convey through the pipeline here. Through a section of stainless steel tubing, and then a bend through a section of flex hose and back through some stainless steel tubing. Total stainless tubing is about 60 feet. That section of flex hose about 25 feet. Conveying back up into the flex hose again. Product will convey up to the mezzanine to the PIAB. You can see there's a PIAB up there on the mezzanine with the hose connected to it. Total transfer distance is about 110 total feet, 15 of that being vertical and the remaining being horizontal. So here we have our PIAB here. This is an older model but still good for lab use. 56 body, so it's the 56 piFLOW P56. We have a discharge cone down at the bottom with the bottom valve flap there contained behind that module. Controlled by a pneumatic actuator. Valve is currently in the open position. Indicator when it's horizontal. Valve is in the closed position. Also on the discharge on this unit we have a fluidization cone like the feed station below. Same concept, a low pressure air curtain behind a high density polyethylene cone gives a nice air curtain to prevent product from hanging up on the conical wall here. Moving up the unit, we have the inlet. Inlet here is a 4-inch, transition down to a 3-inch hose. Behind here there's a filter body. There are 7 filters behind there. At the end of the conveying cycle we'll break it open and show you the filters after conveying. On top here we have our 1200 size pump. This is a lab unit, so this is a little bit older style pump, but it still performs the exact same properties as the new ones. The new ones are a dual side mount pump, reducing your overall height of the unit. This unit here is controlled by our PLC in the lab via pneumatic signals. So we have our calcium carbonate here in the feed station. As you can see, the product does kind of lump on itself a little bit, compacts a little bit, breaks up fairly easy. I'm going to turn on the fluidization function on the feed station so you can see kind of the function that happens when the fluidization is activated. As you can see, it kind of percolates the material, gives it a nice air curtain below it to allow the product to free flow down into a feed adapter. Feed adapter settings on this one so far, we're going to start off with 50% open on the front. Give it some carrier air as after the product entered the product in the stream. And 50% on the rear. Give it some carrier air behind it. Timing sequence on this one is 25 seconds on, 5 seconds discharge. Then we'll take the product, which will catch here in the bag off the chute from the PIAB and the mezzanine, weigh the bag, and be able to calculate an overall transfer rate for the amount of product that is currently in the feed station. Giving us an overall average hourly rate of hopefully at least 3,600 pounds an hour. Here's the feed station after the conveying cycle. As you can see, there's a little bit of product left in the feed station. Not bad. To be expected to have a little bit left over, since the product does have a little bit of stickiness to it. Here we have our product in the bag here on the scale. We conveyed about 81.8 pounds during those cycles. So here we have our product here in the feed station. Calcium carbonate. It does have a very high angle of repose. In the feed station, below the feed station, we have a feed adapter. In the feed adapter are two aspiration valves. The front aspiration valve is currently set to fully open, as well as the rear aspiration valve is fully open. What this will do is allow as much carrier air as possible and convey the product in dilute phase as possible. The feed station is also fluidized, so behind this cone here, there's a fluidization cone, kind of like an air hockey table. Give a nice fluid bed for product to flow directly into the product stream, preventing any bridging or rat holing. Product will then convey down the convey line here through some stainless steel tubing, through a section of flex hose around the bend here, and back up against some more stainless steel tubing, up into another bend here, where the product will then convey up into the mezzanine, into the PIAB. PIAB up top is a 56-liter unit, the 1200 pump. Product will convey into there and discharge through a fluidized discharge as well down the chute, catch it here in the bag. Once we're done conveying the product, we'll weigh the product in the bag and be able to calculate a rate based on the transfer time it took for this amount of product to convey. So now we convey the product here. Transfer time is set for 25 seconds of suction, 5 seconds of discharge. This will allow the product to convey in almost a complete full transfer volume into the conveyor. During the conveying, we'll also actuate the fluidization, which will help to aid the product into the product stream without preventing any sort of bridging or rat holing. Go ahead and start it here. We have our product in the bag here on the scale. We conveyed about 81.8 pounds during those cycles. So now let's show the inside of the PIAB after conveying some of the calcium carbonate. The inside of the PIAB, there is a little bit of product on the walls of the PIAB, to be expected, since the calcium carbonate does have some sticky properties to it. But as you can see, it releases right off the wall. Nothing permanently stuck there. So you have the discharge there, product discharge down the bottom. There's a slight coating on the fluidization cone. Cone is white itself too. So, and here we have the filter assemblies. There's some product on the filters. The air shock for this lab unit doesn't function very well. So in a normal operation, this would be most likely after a long run of product. This assembly here has different types of filters. We have a pleated rod filter here, as well as a pleated filter. The pleated filter does have more surface area. We're just limited to what availability is here in the lab. As you see, there's not a whole lot of product on there, just a little bit. And at the end of every cycle, it will pulse and clean itself. Product inlet looks good as well. No product caked up or settling in the inlet there. Overall, it looks pretty good.